Good afternoon, everyone. My name is Tae-Jung. I'm from South Korea. The topic of my presentation today is hybrid color space-based road sign detection technique. Contextualize. I will explain about road sign recognition and Korean road sign feature in detection. And I will describe the proposed algorithm, hybrid hue normalized-based RGB segmentation. Driving assistance systems are systems to help driver in the driving process. When designing with safe human-machine interface, it should be increase car safety and road safety. Example of such a system are driver drone is system, detection system, and here descent control, and adaptive cruise control, and lane departure warning system, and pedestrian protection system, and so on. Road sign detection is a kind of driving assistance system that automatically informs driver of road sign information. Generally, road sign should be designed and positioned in such a way. Meanwhile, traffic sign recognition has been performed only for traffic safety sign. Speed limit, children or tunnel head, and other signs are examples of traffic safety sign. This information is designed to be easily recognizable. This technology is being developed by many researchers and automobile manufacturers. Currently, traffic safety sign recognition results are displayed using head-up display and navigation system. The road sign has more information than road safety sign. For example, distance, road number, neighborhood junction, distance to the destination, and so on. Road sign, like road safety sign, has rules set by each country government. Information of road sign depends on installation site. The idea is to improve road safety by assisting the driver. It may happen that the driver is tired or misses the road sign. Korean road sign can be divided into 5 categories: landmark, distance, direction, road number, and other. The other categories include tourist sign, rest area sign, motorway, and so on. Each category has different characteristics and applications. This figure shows an example of traffic road sign by Korean government. Color, size, installation site, and characteristics in each category are regulated by Korean government. For example, this direction sign has blue background color. It means this road sign is indicate a rural area sign. This road sign should be installed in front of 10 to 30 meters from the crossroad. Similarly, the size of letters and shapes, there are fixed rules. In South Korea, the 3 background colors of blue, brown, green color are generally used for road sign. Generally, character and symbol of road sign is white. However, blue and green colors also used for certain signs. Most road signs are represented by multiple colors and categories. Using this feature, you can identify the road sign and other objects on the road. Our proposed road sign detection scheme can be summarized as this flow chart. From a video sequence, determine the line indicating the road using a hub transform. Initially, bottom 30% area. After this process, you can get the line information with angle. And the number of line is greater than 0. Progress to the next. Using angle information can be found on the intersection of lines. After that, set a search area. This process is carried out in order to reduce the computational complexity. Find the load sign using high-color-space-based procedures here. If that load sign is listed, then noise will be removed. This process is repeated for each frame. In this paper, I propose load sign detection technique using hybrid color space. Perform this step. This histogram was obtained in the area of load sign, including all average hue values for different times of day and night. As you can see, blue color sign boxes can be easily classified, but blue and green colors are close to each other in few domains. To achieve proper segmentation, another feature space should be used, since our primary aim was to classify the blue and green colors. Normalized blue and normalized green are treated as primary features. This figure shows three-dimensional histogram of hue and normalized green and blue. As you can see, green and blue peaks appear at different points and groups. So using simple cross-line algorithm or some studies using threshold, the three kinds of traffic load sign can be distinguished easily. Experimental result. We initially captured traffic scenario using an HD camcorder affixed to the front of glass of a moving vehicle. The traffic scenario was recorded with HD resolution. To get different illumination characteristics, training sequences were captured at different time and places, including morning, evening, and night. Training sequence data were obtained from 13 places. Training and validation set were separated into different environments for reliability. This result shows hue saturation based segmentation result and our proposed hybrid-based segmentation results are shown. This result is obtained in the same video frame. In hue saturation based segmentation result, there are a lot of noise around the load. But in our proposed hybrid color-based segmentation result, load sign region is remained, but some noise has been removed. This remaining noise can be removed easily using side check or aspect ratio and other features. Purpose scheme is applied at 20 frames per second for HD video sequence. Our proposed hybrid color-based technique efficiently detects load sign in both urban and rural area sign. From this figure, our proposed approach can detect traffic load sign with little noise. This noise was generated because it is similar color with traffic load sign. As mentioned earlier, noise can be removed easily. Some techniques. It is remaining load sign. I propose a hybrid color space-based traffic sign detection technique for the South Korean environment. Our proposed scheme is simple to implement and can efficiently detect and roll sign under different conditions in both urban and rural environment. Proposed scheme is applied at 24 frames per second for HD videos. This technique is real-time in nature and can be applied for driving assistance system. This is the end of my presentation. Thank you.
Thank you very much. Are there any questions?
So, did you also calculate it in the bounding process, or did you just have the detection, pixel-wise detection?
Yeah, pixel by pixel.
Is there further planning for introducing bounding boxes to sort of cut out the image region of interest?
No, in this paper, full frame search. Yeah.
No, is there any further studies? Is this going on?
Yeah, set the search region after that. In the search area, perform this highway cross-place technique.
Okay, thank you.
Some other questions? I have a question.
I'm not familiar with this hybrid color space, but how do you calculate the normalized green and normalized blue color channels?
How to?
Yes.
In the green colors, in the same pixels, the pixels divided by sum of 3 RGB colors. Yeah. Right. You can say? No?
So,
I don't understand.
because you make some kind of transformation from RGB to blue, normalized green and normalized blue color space.
Yeah.
So, like HSV color space. And what's the calculation of the two channels? Normalized green and normalized blue.
Yeah.
I can't imagine how it is calculated.
I'm sorry, I cannot understand your question.
So maybe you have a formula for it. Calculation from RGB to normalized blue.
Yeah.
You basically have the RGB values when you take the picture, right? And then you have to combine them somehow and get it into the hue space in order to see if it's in black or in white. And then you take out the points which are not connected to the salt and pepper. You have to somehow from the RGB space move into the hue space, and then you have to make this calculation. You have to do some kind of formula in order to get from the free information on the RGB space into the hue space. Do you have this formula, or can you provide us more information on how this transformation is done? That was the question.
Each color space, each normalized color space divided by sum of 3 RGB colors, and can get each normalized blue or green and red by sum of 3 RGB color space divided by.
Maybe we can take this offline and go in the config break, which I've already started for 5 minutes. Let me thank you.